Welcome, good morning, and good afternoon to Eaton Nation. I am Josh Kingsley, your host for All Things Control by Eaton. I want to welcome everybody to our Ask the Expert session for PLCs. And today we have two special guests. You know the first guest as the product manager for control and automation. Please welcome Adam Bainbridge.
Hello, everybody.
Also joining us, we have your friendly neighborhood application engineer. Please welcome Travis Quinn.
Hey, guys.
Good day, gentlemen. As a quick note to all viewers, you can ask questions via the comments sections below on LinkedIn or Facebook, and we will do our best to answer as many of them as we possibly can. And then one more thing, this session was brought to you by the Easy E4 Nano PLC. Please visit eaton.com/easye4 to learn more about the product. And if you want to learn more about PLCs, visit eaton.com/automation compass to explore our contents. All right, gentlemen, let's get to work. And it looks like our first question is coming in from the LinkedIn world. This one is from Henry G. And so the first question, what is IoT in relation to a PLC? Travis, please engineer us an answer to this one.
Great question. So the IoT, or the Internet of Things, describes a network of physical objects for the purpose of passing data between devices and systems such as servers over the internet. PLCs such as the Easy E4 have always been doing this historically on subnets, in other words, local networks. However, the introduction of IoT now takes this concept to the next level by exchanging data over the internet. So a good example of this is how the Easy E4 allows a user to send an email from a PLC to a recipient via the internet.
Okay, wonderful. Thank you very much, Travis. And Henry, hopefully that cleared everything up for you. Looks like the next question's coming in also from the LinkedIn world. What are the different components of a PLC? Adam, as the PM, I think that one's going to be great for you.
Yeah, really good question. So there's three main components to a PLC. There's the base devices, the communications, and the expansion modules. These three devices make up, typically combined in different configurations for different applications, but the base device is the CPU. It does all the thinking and processing of your program. The communication unit brings in digital information, so it communicates using standard industrial protocols, gets status of communicating sensors, drives, devices to the logic program to be processed where decisions can be made. The expansion units, finally, are physical I/O cards that take physical sensor inputs, physical relay outputs to control contactors and motors directly. So those are the three main components: base devices, comm units, and expansions. Thank you.
Oh, good. Sounds good. All right, we're going to go ahead and bounce over to Facebook here for this next one. This one is coming from Janice. And Travis, I think that we're going to have you do this one here. What are the common applications of a PLC? As an application engineer, I think you have some good answers for this.
Absolutely. So a PLC can be used pretty much anywhere that you need to automate a process. I guess key thing to note there is really you typically want to use the PLC in situations where you don't want to use an application-specific processor. So those situations would be either flexibility requirements or cost. So I guess some examples of where you would want to use a PLC would be definitely in process control in applications such as water sanitization, HVAC systems, or otherwise food and beverage production.
Gotcha. Perfect. Okay. Looks like we're going to be hopping right back into the LinkedIn world, and we're going to go to Adam with this one. So how does an HMI communicate with a PLC?
Well, that's
from Ben. Sorry.
Okay. Sorry. Yeah, really good question. That can be complicated, but in the simplest terms, your PLC has a tag list or variable list that you build when you create the program. That tag list or variable list is imported into the HMI, and the HMI, using its communication drivers, synchronizes the data between the PLC and the HMI using standard industrial protocols. Ethernet IP is a very common option in our Americas region. So once that's imported, you have that physical layer. It keeps them in sync, and you can use them in either program and synchronize that data between the two.
Gotcha. So more than anything, it sounds like they interface pretty well together and that they're generally made to work together. Is that a fair statement?
Very easy. Yep, simple to set up.
Okay, good stuff. And then just quick sidebar question. How does the nanopod, which I've heard is a really effective device, connect in with those?
Yeah, I think you made that thing up. That might be some kind of alien communication thing. I'm not really familiar with it.
Sure. Well, if you can get that to work, I would love to, see what they have to say. Back to the actual questions. We got Chuck Z from back in the Facebook world. This seems like a fairly complicated question. I think we'll start with Adam. I have a variety of customers that deal with a variety of voltages for their applications. Is there such thing as a PLC that would work for all of them?
Not exactly all of them, but we're getting very close. You are correct. There are different power supply and power standards throughout the world. And even within each region, different applications have different requirements. 12-volt DC is commonly used in mobile applications, so mobile refrigeration, trucking, things like that. 24-volt AC is used everywhere in the HVAC industry. And then you have their standard 120-volt, 240-volt, and then you have some high voltage DC used in some rail and transportation industries. We have something we call UC, universal current, that accepts both AC and DC. So with one PLC, you can take 12-volt DC, 24-volt DC, or 24-volt AC, which really simplifies the choices that you need to make, the number of inventory you need to carry. And then our high voltage AC devices can take between 100 and 240 volts AC, again, simplifying the selections that you need to make.
Okay, good stuff. Travis, I do kind of want to bounce to you to weigh in on this as well. All the time that you spend in the field as an application engineer, why are there so many different voltages? I mean, it's great that there's products available that can cover some of this, but why do we have to get to the point where we're covering that way?
Sure, good question, Josh. A lot of it really boils down to tradition, as Adam was kind of alluding to. So the United States, historically, a lot of your control voltage is either 24 DC, otherwise 120 AC. But when you go across the pond over to Europe, a lot of times their outlets, for instance, or their control voltages are a lot of times 220 volts AC. So it really, again, just boils down to tradition. However, there are some benefits to using 24 DC compared to 110 AC in the US, such as you don't have to use gloves once you're underneath 50 volts. So if you need to enter a panel using lower voltage applications, definitely have an advantage.
Gotcha, good to know. Well, I'm glad to have the universal current to try and teach some old dogs some new tricks. Looks like this next question is coming back from LinkedIn. This one's from Frank, and I do want to point out that this question is also something that was of great interest on the LinkedIn event poll that we sent out pre. So again, thanks to all the viewers that we have on today that participated in that poll. That was good to get the pre-feedback, but this specific question is going to be about PID control. So what Frank wants to know, what is PID control? And what is a common application for implementing the control scheme with a PLC? And Travis, this seems like a perfect question for you again.
Sure. So PID stands for Proportional Integral Derivative Control. However, in 90% of the applications, usually all you need is proportional and integral control. So proportional control directly scales the error between the set point and the feedback to increase or decrease the initial response of a system, so the reaction of a system or a step change, if you've heard that term before. Whereas the integral gain scales the accumulated error at that point in time. It's very useful for eliminating steady state error that usually can't be corrected by proportional gain alone. So a common application for PID control with a PLC would be, for instance, controlling the speed of an exhaust fan to maintain a temperature in a room. So the PLC will either speed up or slow down the speed of a fan via a VFD in order to blow more or less hot air out of the room, which then, of course, would increase or decrease the temperature of the room to maintain that set point that you're desiring.
Adam, anything to add to that?
Yeah, absolutely. So proportional integral derivative control sounds really complicated. A lot of people, may want to avoid it. Going to the application example Travis presented of using that exhaust fan to kind of regulate temperature in electrical control room, something like that. It's very easy to just slap on an on-off temperature switch. So it turns on at a certain temperature, has a little bit of hysteresis and shuts back off. The downside is you don't get very accurate temperature control. The temperature swings within that range. And also you don't realize any energy savings. So having a fan run full speed, consuming full load amps is maybe okay, but if you put a variable frequency drive on the system and reduce that fan to half speed, you get significant energy savings. Even if it's running the same amount of time, or even half the time, you're still saving a significant amount of energy in that application. So you get better temperature control, energy savings, and it really isn't that complicated with modern technology to set up. Simple temperature sensor, some kind of PI controller, which could be on the Nano PLC, could be built into the VFD itself, and it's really going to give you much more precision and, again, save you energy, which is a big deal.
When you're talking about saving energy in a commercial building type of setting, that can be a pretty needle moving amount of cost savings, correct?
Yeah, motors in commercial buildings are one of the greatest loads, second to lighting. So reducing the power consumption of any motor by varying its speed is a huge advantage.
Gotcha. Well, glad to know that we have the ability to help our facility managers out there in the world. So it looks like the next question that I have coming in is going to come in from the Facebook world, and this one is coming in from Jen. And the question is, what is the difference between PLC and RTU? And I think that this is really a result of throwing a lot of acronyms around. So Adam, can you clarify, please?
Yeah, so PLC is Programmable Logic Controller. RTU is Remote Terminal Unit. They both process logic. They both control things. I would say just traditionally, the PLC has always been easier to program. They ultimately do very similar things. They both, they're reading inputs, reading outputs, making decisions, or writing to outputs, making decisions. But the PLC uses much more standardized code, which makes them, very easy to implement in sequential logic operations.
Gotcha. Travis, anything that you would add to that?
I think Adam spelled it out pretty clearly. The PLCs definitely tune more towards the industrial world, common applications such as IEC 61131-3 programming, etc. So really, again, it's a lot more commonly used, which makes it a lot easier to kind of pick up and tune in, calibrate, so to say, for pretty much anyone versus the RTU.
Gotcha, perfect. Okay, looks like we have our next question from Nelson on LinkedIn. Would I be able to debug your PLC software in Linux? If so, please inform me if I could erase, it looks like EEPROM or PROM memory or strictly the RAM cache memory. Adam, can you take that one, please?
Okay, that's definitely an in-depth question, Nelson. So you're wanting to debug it from a Linux-based system. So our EasySoft application, which interfaces with the software, is a Windows-based tool. So you can do all of the functions you described from Windows for sure. You cannot run EasySoft from a Linux-based platform. So there is that limitation, unfortunately. However, the Easy E4 does have a API, which is an application interface that allows you to interface with the device over JSON. So many of the commands that you're asking for, you could write and interface directly with that tool and read and write data and do diagnostics. Unfortunately, just be a little bit more manual, but could offer a lot of flexibility in your application. So I think it's a very powerful feature having that API available for you to work with in those environments.
Travis, have you gotten into a situation like that before where you could comment on anything further?
Really, that's a pretty unique situation. I actually personally have not run across that yet. I guess really, I think I also heard something about resetting the module. So I'll just chime in there. There's also a built-in not a USB, there's a micro SD card that also can be used to reset the device. So there are some manual ways of resetting the device and getting the configuration that you need built into the device as well.
Okay, so I'll ask you a quick follow-up question. What other benefits would you have by having the micro SD card reader on there? Can you preload programs, things of that nature?
Yep, you can preload programs. You can also have little bitmaps to actually load an image when you boot. You also can log data to that card as well. So there are definitely multiple features that are very useful when using that SD card.
Gotcha. All right. Any more questions from the field? It looks like we're pretty prepared to get into your in-depth specific application situation. So keep them coming. All right. Well, at this point, it looks like I'm actually getting the cue from the producers, and they're reminding me that we do have. Oh, hold on. Looks like we got one more question coming in here. Just need a second to read through it. So I guess, Travis, I do have a question that I could ask you while I'm getting this one to come in. What's
Sure.
the most unique PLC application that you've seen in the field? What's the most unique project that you had the opportunity to work on?
Ooh, are we talking specifically to the Easy E4, I'm going to assume?
I would say in the nano PLC space
Sure.
in general, what kind of scope of applications are a nano PLC going to cover, and what's the most unique one that you've had the opportunity to work on?
Sure. I'm not going to consider it super unique, but I'd say one of the most beneficial methods that I've definitely seen is using the nano PLCs basically as remote I/O. So when you have a nano PLC, just the cost benefit alone with the built-in I/O, you can then interact with it to read and write data or turn on and off outputs directly over protocols such as Modbus TCP. Super beneficial also because then you can also run some minor logic, maybe remotely too, right in the PLC, and then report or funnel up some of those calculations back to a main controller. So there's definitely been customers that have kind of used that sort of architecture as well.
And I'll add a little bit to that. So, nano PLCs have really blurred the line, the current generation that is in applications. I mean, you used to have these dedicated PID controllers, dedicated temperature controllers, dedicated flow controllers. You could have a dedicated counter, timer relays, things like that. I mean, the price point is so low on these nano PLCs that you can easily consider doing a nano PLC in those simple applications to replace a counter, and then you have expandability in the future. Conversely, it used to be I/O count was your limit. Nano PLCs typically weren't very expandable. Now with the EZ4, you can get up to 190 I/O points, something in that range. So the number of I/O is rarely the limiting factor anymore. It's really about processing speed and the type of control that you need. So the nano PLC is a great fit for upgrading from simple dedicated controllers, or even thinking about some PLC applications where you just need a millisecond response time, second response time. But if you really need much faster, hyper accurate position control, you'll probably need to bump up to a higher class, the micro class of PLC devices.
All right, thank you very much. And it looks like we did have a couple more questions come in. But real quick, I want to say hi back to people all over the world. This is awesome. We have some representation from down in the Caribbean, from the Dominican Republic. We've got some African friends from Morocco. We've got South America, Peru. We've got Mexico, and then we've got a bunch of European places, Switzerland, Italy, Russia. We have some Asian countries, India. We have Turkey, which is both European and Asian, and then Nigeria, Toronto, of course, the US, Spain, Tunisia. This is exciting. Glad to have so many people from all over the world tuning in to listen to Adam and Travis drop some knowledge on us. And the next question that we're going to have is, can a PLC be learned with help online courses? Can it be learned with help from online courses, or is it required to have the equipment? So what would be the best way to learn about a PLC? And this is from Syed on LinkedIn. And so I think what they're looking at is, if you need to learn how to program a PLC, what's the best way to go about doing that? And Travis, I think you've had to learn how to program a lot of PLCs, so I'll let you answer this one.
Sure. So Eaton right now is definitely working on some training classes. We do have some in person. We're working on getting a lot of that information up and available for customers to use as well. That training is very beneficial. Even if you do download the software itself, you can definitely play around with it. There are built-in simulators to help you also play with that logic, and you can get some feedback without having a device. But really, if you do want to physically have it in front of you, I would always recommend trying to purchase just the basic components, because I really do feel that interacting with the device is the best way to really learn about it.
So I want to add to that, if I can.
Yep, go for it.
So yeah, you can download EasySoft for free. The only restriction, if you do not license it, is you cannot download to a device. So you can get in, you can play. We do have videos available online. I think there's 7 at the moment, something like that, on our webpage. So watch those. They cover basic things like starting your first program, downloading it to a device, using basic function blocks, things like that. So to answer your question very specifically, yes, you can learn this thing very easy. It is very simple to program. We do have tools available online where you can pick it up very quickly. But as Travis said, we do have a starter box that comes with a cable, comes with a software license, and comes with a base unit device that you can purchase if having a physical device will make it easier for you.
So quick follow-up question. Travis, you did mention get the basic devices to put everything together. Are you insinuating that it would be nice to have a small motor to simulate an application, or what do you mean when you say have the basic devices around?
So I guess what I meant for the basic devices that in that last sentence was making sure you have the base unit, and then we also have a variety of expansion units with the Easy E4. So if you need analog outputs, for instance, we typically do not provide those on the Easy E4 base unit. So if you need some of those features, I guess that's what I was referring to when I meant get the basic components of what you feel that you need for your application. You don't need to go out and go crazy and buy all sorts of things, or get too complicated. So if you're just starting out and going through some of those videos that Adam was alluding to, what I think I meant was the base devices that you need for your system or application are typically all you would need to get up and running.
Okay, outstanding. Thanks for that clarification. Next question that we have, and this is from Euclides on LinkedIn. Any recommendations on an applications or reference manual for PLC controllers for medium voltage switchgear? Adam, can you take that one, please?
Any reference manuals? Was that the specific question?
Yep, so recommendations on application or reference manuals for PLC controllers with medium voltage switchgear.
So that's a good question. Yeah, I don't think we do have, of course, manuals for the base devices itself that covers, implementation of the different blocks and stuff within it. Anything specific to switchgear, to be honest, no, we do not have any documentation on that, but feel free to reach out to me or Travis. and we can help you with those applications. If there's specific functions such as transfer schemes, things like that, monitoring, we can absolutely help and point you to the right function blocks to assist you in solving those applications. So I think in this case, the best bet may be to reach out, consult with us, and we can point you in the right direction.
Okay. Is the best point of contact in to work through the Technical Resource Center, through you guys directly?
Technical Resource Center is always a great place to start. They have a lot of in-depth knowledge with the products. But yes, feel free to reach out to Travis or myself as well.
Okay, perfect. Let's see here. I'll do one more quick last call for questions from our social media centers. All right, and it looks like we covered pretty much all the questions, and now I really do have the producers in my ear right now saying, you know, hey, don't forget we do have bills to pay, so I do have to, you know, go and show a product off. So please do stick with me for one more final round up of, and then we'll go, you know, close everything out after this message from our sponsor, the Easy E4. All right, thanks again to the Easy E4. We did have a few more questions come in that I want to try and get through. So Amir on LinkedIn, what aspects of enhancements are still needed for a programming logic controller, both hardware and software, especially when it comes to dealing with IoT issues? Adam, do you want to do that one, please?
What issues are enhancements?
Yeah, so what aspects of enhancements are still needed for the PLC hardware and software when you're dealing with IoT issues?
Yeah, I mean, you know, security is a big thing. That's always going to be an issue that is never going to be finished. We're going to have to continue to solve that every day and keep an eye on current threats and on awarenesses. As Travis mentioned earlier, you know, we already have email servers within the Easy E4, so you can connect it to the internet, and it can send those email messages and alerts out to any support staff or building owners or plant operators that you may wish to. That's already in there, and cybersecurity it's been tested and it's ongoing. I think other issues is, you know, we'd like to do more. We'd like to get more data collection out of these devices. We have the APIs, which enables you to extract the data into the platform of your choosing. But I think that could be simplified, make it easier for the end user, and then that's something that we're going to continue to work on. So I hope that answers your question.
Okay, perfect. Looks like we're going to be able to get one more in. So Travis, if you could quickly answer Ola from LinkedIn, what maintenance process is required for a PLC?
Sure. Typically, the PLCs themselves are sealed up pretty well, so maintenance on a PLC, especially when it's within a panel, is very, very low. There are some PLCs that do have batteries in them for their real-time clocks, which may burn out eventually, and that's typically only the only sort of maintenance that they need, honestly. These PLCs have been around in the industrial industry for a very, very long time, and they're basically bulletproof at this point when it comes to maintenance.
Perfect. All right. Well, we are at that time, so we do need to wrap up. So please don't forget, for more information about the EZ4, please visit eaton.com/EZ4. And if you would like more help with your PLC applications, please visit eaton.com/automation compass. And I want to thank you again, our guests, Adam and Travis. Thank you guys very much for being here today. And then also thank you, the audience, for being here with us. It's been our pleasure. And once again, I'm Josh with All Things Control by Eaton. And until we meet again, which we will, don't forget to keep it in control.